Hi, I'm Mrs. Burns and welcome to Lesson 3 of our Chapter 9 unit on linear relations. Today we are going to look at the patterns that we can see based on the numbers in our table of values. So let's review that a linear relationship is a relationship that when you put it on a graph, it shows you a straight line. We can draw a graph from a table of values, or you can figure out the table of values based on a given graph. So let's look at some definitions here that we'll need to know today. I'm going to be using the word variable a lot, and a variable is simply a letter of the alphabet that represents an unknown quantity. So if you don't know something, maybe you would say X. But we're going to see a lot this letter T, because I like to use T for a representation of time. So maybe sometimes you have X, sometimes you have Y, sometimes you have N, sometimes you have T. Those are all variables to represent some sort of unknown quantity of something. An expression is a number, or it can be a variable, like a letter, or a combination of letters and numbers. And they make up a statement that does not have, it is without an equal sign. So some examples of this would be like our letter T or the number 7. Those are both different expressions. Or maybe X plus 9 is an expression. Or maybe you could even have 2y minus 3. So that's 2 times the y minus 3. So that's an expression, that whole chunk there on each little line. And we don't have equals something. So that's an expression without the equal sign. And the last definition that we need to know are consecutive values. And that means that when for one variable, so the X or the A, the difference between the numbers side by side, so one number minus the other, so the difference between two numbers that are side by side is the same as the difference between all side by side numbers. So let's look at an example. If X has the values of 2, 4, 6, 8, 10, 12, you see that from 2 to 4, we add 2. From 4 to 6, we add 2. From 6 to 8, we add 2. From 8 to 10, we add 2. And from 10 to 12, we add 2. So every time the difference between two numbers side by side is 2. An example where this is not the case. So a non-example, that means that this example I'm about to show you, they're not consecutive values. If for X the values are say 1, 2, 3, 6, 7, 9, 12, for example. So here 1 to 2 you add 1. 2 to 3 you add 1. So that looks so good so far, but now from 3 to 6 you add 3, and from 6 to 7 you add 1, but from 7 to 9 you add 2, and from 9 to 12 you add 3. So that's not consecutive because the difference here between 9 and 12 is 3, but the difference between 7 and 9 is 2. So when the numbers do not always give you the same difference, then they're not consecutive values. Let's look at an example here. The first example of the day, I've already drawn in on my graph my straight lines because I find that hard on the computer here. For this table of values, we have the variable A and we have the variable B. And for A, we see that numbers go from 0, 1, 2, 3, 4. So let's graph the x-axis here as A, and we have to go up 1, 2, 3, 4. So if this is 0, we could do maybe every other 1, 2, 3, 4. Every other box will count as 1. And then for B, we have each one is going up by 3. So these are all going up by 1, and these are all going up by 3. You can add that in if you wish to all of them. So here we have 3, 6, 9, 12. So if the y-axis then is B, then we have, say, 0 on the bottom, and we could go maybe 1, 2, 3, 4, and these are all along the line. 5, 6, 7, 8, 9, 10, 11, 12. Well, here we see in our table of values that it tells us all the ordered pairs. So remember that when we graph, we want to do the A then the B, so we would have 0, 0, we would have 1, 3, we would have for A is 2, B is 6, we would have 3, 9, and we'd have 4, 12. So we can graph all of these points to see what it's going to look like. So the first point, 0, 0 is here. 1 on the bottom, fall out to the 3 for the y-axis, the B. A is 2 when B is 6. A is 3 when B is 9. And A is 4 when B is 12. So there we go. And that is our graph. Let's flip to the back and see what else we're supposed to do. What is the difference? Here I put the chart again so we can keep going. What's the difference in value for the consecutive A values? Well, we saw that if you do this number minus this one beside each other, you get 1. If you do 2 minus 1, you get 1. And if you did that with all of them, you'd see that the difference, I'm just going to write difference, is 1. And what's it for the B values? Well, here this would be like 3 minus 0 equals 3 there, or 6 minus 3 equals 3. And this is a way that you can double check that, yes, for sure, this is a linear relation because these are always the same difference. 9 minus 6 equals 3. So here the difference for the B values is 3. Okay, let's use words to describe the pattern that we see between these A and B values. Well, when I look at this chart, I see that the A values are always going up by 1 each time. It's always plus 1, and the B values are always going up by 3 every time. So this one is always plus 3. Now, I could say that for every 1 change in A, that's my variable A, there is a 3 change in B. For 1 change in A, there's a 3 value change in B. So we could say another way, each B coordinate is 3 times the A coordinate, because every time that B goes up by 3, A goes up by 1. So that's how I could use it in words. I like this one the best. Each B coordinate is 3 times the A coordinate. So we could also see this here, 4 times 3 is 12. 3 times 3 is 9. So that works. What's an expression for B in terms of A? That's a really tricky question the way it's worded. So basically what I want to say is, what if I'm not allowed to say the letter B? How could I tell you what B is without using the letter B? Well, I know that B is 3 times each A, because if I want to figure out this value here, I would take the A and I would times it by 3. 1 times 3 is 3. So I know that B is 3 times the A, so B can be written as 3A. So this is a way to say the letter B, is just by saying 3A instead. So an expression for B in terms of A then would be 3A. What is the ordered pair here? So we know that the ordered pair always goes A, B, but when I show this, I want to show them both using just one of the letters. So here I've already changed B into A, so let's show them both as an A. So let's put them both in terms of A. A stays the same, but instead of B we can say 3A. So this would be my ordered pair. Please read over your notes before coming to class next day, and we will unpack this a little bit further.